All right, so this page is we're gonna start on page 5. So we talked about this towards the end of the video, and the last one is what if there's kind of it's not perfectly perpendicular, there's some kind of force going that direction, but not completely. So what I mean by that is, what if I had a force that looked like this? Okay, it's kind of a mixture of vertical and horizontal, but let's say my distance was going this way. Okay, so what I can do is I can actually figure out how much of my force, so if this was your original force, I can figure out how much of my force is going in the horizontal by using my trig functions. Okay, so we're going to give you an angle. So if I wanted to find fx, so here's your triangle. Okay, this would be the adjacent side. So the only one that uses adjacent hypotenuse is cosine. So if you want to find your horizontal component of force, you would do your hypotenuse times cosine of your angle. Just make sure you're in degree mode. Anytime you do anytime you do sine, cosine, tangent, you need to be out of radians and into degrees. So a fisherman pulls a rope along the dock. Okay, so pulls a boat along the dock with a rope. So we're going to draw a dock right here. Okay, our fisherman, we'll say Bob's back. Okay, he's got a rope. Okay, and he's trying to pull this boat towards the dock. Okay, he's going to pull it 30 meters, and he's got an angle of 60 degrees, so your angle would be right here. And he has a force of 255 newtons. Okay, so he's trying to pull that thing towards the dock. Now, are we pulling the boat out of the water? No. Okay, so we're looking for how much of Bob's force is going in the horizontal direction or the way that the boat is going. So let's kind of zoom in a little bit here. So my angle would be 60 degrees. My hypotenuse is going to be 255. Okay, if my boat is moving horizontally, I need to figure out what is my horizontal component of that force. So we're going to do Fx equals 255 times cosine of 60. And that gives you 127.5 newtons. So that is how much of that force is actually moving horizontally or pulling that boat towards the dock. Okay, so now we actually have our force, our correct force. So now we have force, we have distance. Okay, so we can do work equals force times distance, so 127.5 times our distance. We pulled the boat 30 meters. Okay, multiply those and you get 3,825 joules. Okay, I have a man pushing a lawnmower with a force of 75 newtons at an angle of 40 degrees above the horizontal. Okay, so let's do our lawnmower. So let's just do a basic lawnmower. Okay, lawnmower's going this way. Okay, our angle is 40 degrees above the horizontal, so here's our angle. Okay, I'm pushing down to 75 newtons. Okay, how much work is being done if the lawnmower is pushed 55 meters? So I know it's going 55 meters this way. But I need to figure out how much of that force is in the same direction, so we were looking for our Fx. So Fx equals our hypotenuse, 75, times cosine of 40. Okay, and you get a value of 57.45 newtons. Okay, so now I know how much of that force is actually going in the direction of the lawnmower. So now I can plug in work equals force, 57.45, times my distance, which is 55. And I get 3,159.75 joules. Okay, moving on here. So how much work is being done? So how much work does gravity do on the 2 kilogram book if the book falls 3 meters? Okay, so remember work equals force times distance. Okay, so I have mass, I don't have force, but remember weight is a force. Okay, so my force is going to be mass times gravity. So mass will be 2. And since gravity is the one doing the work now we're going to make this negative 9.8. So that means the weight force is going to be negative 19.6, okay, newtons. So now I know my force, so I can plug in, so negative 19.6. And now it's falling 3 meters, so that's going to be a negative 3, which is going to give me a value of 58.8 joules. So that gives me a positive work. So even though gravity is technically negative and it's falling a negative distance, we want those negatives to cancel out because gravity is the one doing work here. Negative work means gravity would be going against the motion. Okay, so if gravity is the one doing the work on this, it's okay to have a positive value because gravity is the only one doing work on this case. Number 2, find the net work done on someone falling at terminal velocity. So terminal velocity means you've reached your max velocity. That means you are no longer speeding up. So if you go skydiving, okay, you will speed up when you jump out of the plane, but you will hit a terminal velocity where that's as fast as you're going to go. Okay, so when that happens, that means acceleration is 0. Okay, you are no longer accelerating. Okay, so if I know that F equals ma, okay, and a is 0, that means my net force would have to be 0 newtons as well. Okay, and if I know work equals force times distance, and F is 0, then therefore my net work is 0 joules. Okay, so you need to actually have a force, a net force, over a distance in order to have work. So that doesn't mean nothing's acting on it, just means your net work would be 0. So we're going to talk about what is acting on that book. So when falling at a terminal velocity, what forces are doing work? So you have the force of gravity that's pulling it down. Okay, and take the book or take skydiving, for example, is what's working against you is your air resistance or some type of friction due to air resistance. So what happens is when you reach that terminal velocity, those balance out and they basically cancel each other out. So even though net work is technically 0, there's still work going on individually. Like gravity's still doing work to pull it down. Air resistance is still doing work to keep it from falling. Okay, but basically what they do is they've matched up together and they've canceled each other out. So your net work would be 0. Number 4, a 20 kilogram box is moved across a 5 meter room by pulling a 10 newton angle, pulling with 10 newtons at an angle of 30 degrees to the horizontal. So we're going to draw our triangle. My angle is 30 degrees. My force is 10 newtons. Okay, I'm pulling across the floor. Okay, so I'm pulling it this way for 5 meters. So I need to figure out how much of this force is in that same direction as that 5 meters. So Fx equals my hypotenuse, 10 times cosine of 30. That means 8.66 newtons is actually going in the horizontal direction. So now I can do work equals force times distance. So 8.66 times 5. And I get 43.3 joules. Now, I know everybody remembers their free body diagrams. If that box is being pulled across the floor, my distance is going this way. Okay, remember, force of gravity is pulling down. And when you're on a surface, okay, the normal force is what pushes back. Okay, so the box is pushing down, gravity is pulling the box down on the surface, and then the floor is pushing back up with a normal force. So if you look at your directions, look at the direction of your normal force and your distance. In this case, normal force is perpendicular to distance. So that means normal force is not doing any work in this scenario. Now, find the work done on the box as the box moves down the ramp. Assume there's no friction. What's causing the box to slide down the ramp? Well, what's causing the box to slide down the ramp is gravity. Okay, so let's take a look at our triangle here. I have a mass of 5 kilograms, I have an angle, and I have my ramp or my hypotenuse, which is 100 centimeters. Okay, first of all, I can't have 100 centimeters, so divide by 100, and we're going to make that 1 meter. So that fixes that. So we're going to figure out how much work is gravity doing. So if you were to look at which way is gravity going, gravity is not going this way. Okay, gravity does not really care about a ramp. Gravity is always in the same direction. So gravity is working this way. Okay, so the force of gravity is going down. So that means if gravity is the one doing the work, that means work has to be going down as well. So again, like I said, gravity didn't care about the ramp. All it cares about is getting the box from here to here, getting it from the top to the ground. So if work equals force times distance, I need force in that direction and I need distance in that direction. I do not have that distance. Okay, I need to figure out what is the height of that ramp. Well, I have a hypotenuse, which is 1. I have an angle, and I'm looking for the opposite. So remember, sine of your angle equals opposite over hypotenuse. So sine of 40 equals opposite, which we don't know, that's x, over your hypotenuse, which is 1. So in this case, hypotenuse really didn't matter. So your height of your ramp is 0.64 meters. So that is your distance. So that's how far gravity is working. Okay, so again, we don't care about the ramp in this case because gravity is only trying to get it from the top to the bottom. Okay, so that ramp could be 5 miles long. Okay, if it's still going from that top to that bottom, it would still be 0.64 meters high. Okay, so remember, work equals force times distance. Do I have a force? Nope. I do have a mass though. So remember, force equals mass times gravity. So we're going to take that 5, okay, times negative 9.8 since gravity is doing the work here. Okay, that gives you negative 49 newtons. Now I have force. Now I have distance. Okay, so work equals force times distance, so negative 49. And since it's falling, that'd be technically a negative 0.64 newtons. So multiply those, and that means gravity is doing 31.36 joules of work. Now, let's say if there's a friction force of 5 newtons, what is the net work done on the box as the box moves down the ramp? So net work just means the total work going on. We're just going to add up all the works going on and see what our total work would be. Okay, so as that box is sliding down, so it's going down the ramp, okay, your friction is the one that, friction force is between that ramp and the box. Okay, so when those surfaces touch, okay, that's where that friction comes for. So your friction force is going against you. So we're going to figure out how much work is friction having to do on this ramp. So work of friction, okay, I have a force, and that's technically negative 5.0 because it's going against you. Now, how long is friction having to work? Well, we're going to look for that. How long is the box in contact with that ramp? Okay, that would actually be 1 meter. So it's going to slide down the whole 1 meter ramp. So your distance is going to be 1 meter. So you have a work of negative 5 joules for friction. So net work is where you add them all up. Okay, so you're going to take the work that gravity did, 31.36 joules, and add the friction force. Well, in this case, we're going to minus it since it's negative. You could do plus a negative, which is the same thing. Okay, or we can just do 31.36 minus 5. And that's going to give us 26.36 joules. So there is your net work right there when you mix gravity and frictional force, frictional work. So what should always be done with the friction value is, one, you should either make it negative or just subtract it. Okay, so again, this question was purely to make sure you're paying attention to friction force, direction, when to make things negative or when to make things positive. Okay, and that'll end that one. In the next video, we'll do more practice on how to solve all these works.